about teams now.
So PA5 is a group project.
Okay.
So find a group to work with.
That's it? That's literally all it is?
Yeah.
Find a group? Bright people?
Yeah.
Got it.
Find a good group to work with.
Neato.
They're all good.
Oh yeah.
You're talking super brightly, and I cannot hear you.
How many people can be in a group?
Up to 4.
Neato.
Yeah. All right, so questions before we get started.
But I didn't know what it was.
All right, so a few reminders. First of all, your SLP final upload is due Monday morning at 8. It's worth 50 points out of 100. So it's a really good thing to upload. Right? My suggestion is upload it today, and then if you want to make more changes to it, make more changes to it over time. What is it?
What's the difference?
So it's your project proposal template.
Do you have to submit if we already got 100% on?
This is not your original proposal.
Oh.
This is the thing that you're going to present at the SLP Expo. So download this, it's a PowerPoint file, edit it, fill it in, save it as a PDF and upload it. So it's a one-pager, okay? Put in your project title, don't call your project title, doesn't look professional. Give your project a name, fill in the date, not comma date, but the actual date, full name of the people on your team, okay? If you have a name for your team, you can put the team name on there also. And then just fill in these sections as appropriate for your problem. It depends what your problem is, but these are basically the sections you're after. Definition of the problem, what the heck are we trying to do? Research and analysis, so what are other people doing? What are some of the possible solutions? What did we discover in trying to think about how to solve this problem? Propose solutions. After that research analysis, what did we come up with? How are we going to come up with this solution? And then potential applications, right? How is this going to change the world? What are people going to do with this thing that I'm creating, right? Be imaginative here, be creative, have fun with it, okay? This is all learning experience. This is all chance to work on something you're interested in working on, have some fun, and market yourself a little, right? So it's a good exercise. It's something you'll do again and again throughout your lives, hopefully. Yeah.
I mean, I recognize that from the previous sheet to this sheet, they're kind of the same content.
Mhm.
Well, what are you looking for from this one compared to the last one?
So you're going to turn this in. We're going to print them out for you. They're going to be on 11 by 17 pieces of a cardboard. And then for the SLP Expo, that last Tuesday of the quarter, you pick this up, you find a table, you put your poster down on the table, and then people will come and walk around the room and read your poster and then hopefully talk to you about it. So it's really, it's a one-page synopsis of your project that somebody can look at and say, oh, I get what you're doing, right? So something that fits like that.
Okay.
Right, whereas the original proposal was a text document that had different sections, and it was sort of for me to understand what you're trying to do.
I mean, as far as information, would you want more from our information, like in depth, or do you just want us to be able to put it in a readable format?
It's a readable format, right? So it's not going to have 50 lines of code or complex schematic diagrams with part numbers and pin numbers and stuff like that. It's a high-level view, okay? It's a little bit like, do you know what an elevator pitch is?
Yeah. So you have 30 seconds to pitch your idea.
Yeah, you bump into the elevator and there's Jeff Bezos riding the elevator up with you to the 18th floor. So you got 30 seconds of his time, captive audience. How do you take this great idea you've been working on and like get it out there and transfer the essence of it in 30 seconds or 20 seconds, right?
You guys are really smart.
Is the solution your project then?
So proposed solution, so my project is, I'll pick on the solar-powered mole repeller, right? So problem definition, moles destroy, X billion dollars worth of gardens every year. And that's a pain. So I want something that will repel moles, but I don't want to kill them. I just want to frighten them away. Okay, that's my problem definition. Research analysis. I can go online. I can buy a battery-powered mole repeller. It's cheap, but it takes 16 batteries, and they only last a day, right? And so that's, you know, expensive and wasteful. And I can get a solar-powered one, but it costs $85,000, right? And the review suggests that this thing doesn't work very well, right? So that's your research analysis. Proposed solution, you know, I'm going to make a little fusion generator, and it's going to drive a little thumper that's going to scare away moles. And I'm going to write some Java code to drive it, right, and control the fusion process. Or whatever your solution is, right? And the potential applications, you know, people with gardens or lawns that don't want them destroyed by moles can use this. So, you know, this is not a business class, right? And this is not a venture capital firm, so we're not expecting you to revolutionize the world with your SLP, especially in the first quarter, okay? But imagine, you know, that this is something that you're presenting to somebody for funding, right? So put the best pieces of it forward and present it, right? So that if somebody looks at this, they can run through it in, you know, a minute by reading it and get a basic idea of what it is you're trying to do, how you're going to do it, that kind of thing. Does that make sense? All right, so download this. It's a PowerPoint. Fill it in, save it as a PDF, and then submit it to Canvas by the due date, which is 8 a.m. On Monday. I gave you wiggle room till 11:55. The thing will slam shut at 11:55, and it won't let you submit anymore. If you submit it late, I probably won't upload it till noon. So, yeah.
Are we allowed to bring anything like physical with us, like part of what we're working on?
Yeah, so for the expo itself, you can bring show and tell. You can bring swag if you want to entice people to come over. You can have, you know, bowls of candy or little toys or whatever, right? This is common practice at trade shows and things like that. If you have code, if you have, you know, a physical prototype or something like that, there's power plugs on the ground. Whatever you think will help you talk about your project. Yeah.
Wait, so is there one of those expo things every quarter?
Every quarter.
What time?
3 o'clock to 5 o'clock, last Tuesday of the quarter.
Okay. Okay.
Okay.
3rd of December, something like that.
Could you put that in the Canvas calendar if it isn't already?
It should be on there.
Okay.
It should have been on there since before the quarter started. SLP presentation December 3rd, 3 o'clock to 5 o'clock, Digital Lounge. So if you upload your poster on time, right, we will send them to the printer. They'll get printed out on nice cardboard, shiny 11 by 17. You can pick those up at 2:30 on that Tuesday. They'll be at the front desk. Find a table and just hang out and talk to people about your projects. All right, other questions on that?
Why do you have 2 coding folders
Say what?
in your like hot or bookmarks?
That's a good question.
Condense them.
Delete
No.
one. Better question is why I have 2 older folders, and 2 business folders, and
Which one's
2
the oldest?
frequent folders. Yeah.
How frequent do you go to the frequent one?
Very frequently.
Okay.
That's basically Discord and text messaging. All right, so next thing, I posted some
Wait, which
practice
frequent do you go
problems for the frequent ones. I posted some practice problems for regular expressions. So these are things to mess around with, right? We've talked about regex for a couple of days. Play around with some of these things. Go into VI, make yourself a test file, and start trying to write some patterns to do these. This is great to work on in groups, right? Because it's a brainstormy kind of thing. Basic pattern searching, right? Find the first Q and remove it from a line. Remove all occurrences of Q from a line. Just straightforward slash pattern gets replaced with, if we're removing just, slash slash. Some things related to anchors, so caret for beginning of a line, $sign for end of line. And then some questions dealing with registers, so taking things that match a pattern, throwing it in a register, using that in the replacement string. We've done some of these, swapping the first two characters on a line, but these kind of get increasingly more difficult from top to bottom, not strictly. And then, some groups, so you can look for any of a number of characters by listing those characters inside square brackets. Or you can look for anything that's not one of those characters by putting a caret in the front to negate the search pattern. So with those and some of the stuff from before, you can do things like, add a period to the end of a line that doesn't already have a period on it. Replace every character except a digit with a hyphen, stuff like that. So just things to exercise with, to play around with. And along those lines, I posted a very short regex summary. This is not all of regular expressions, this is just the stuff we've gone over. But this is enough to do, I believe, all of those problems on that exercise. And this is more than what I have to use on a regular basis to do regular expressions just in my daily life. So it's a small kernel of ways to search patterns and ways to do replacements, but it's a pretty powerful collection. So those are posted on Canvas. All right. If you've been doing Zenity under Cygwin, you may have noticed some weird, funny characters popping up in your files when you build your reservation file and so on. If you look at those, if you go in VI, sometimes you'll see a Control M, sometimes you'll see a \R. And I'll tell you tomorrow how to deal with those, but I want to pull some code off of my Windows partition so I have some examples to actually work with first. And we're going to use sed to deal with those. We're going to talk about sed next. So I'll talk about those tomorrow, but if you're really slammed, you just can't sleep tonight because you're getting these funny characters in your file, let me know and I'll give you a preview of how to deal with them. But this is an artifact. In Unix, when you type a bunch of stuff in and you hit enter, right? Right, so I said hello, cool, bye, and I hit an enter after each one. Right, what ended up in my file was my first line, hello, followed by this \n, that's the new line character, and then cool, followed by the new line, and then bye, followed by the new line, and then an extra new line at the end. So if I cat my file, it's got hello, cool, bye, and an empty line, right? That \n is the way Unix indicates the end of a line. And if I look at my file in hex, that \n, HELLO, is a 0A. It's the bit pattern corresponding to the number 10. That's a Control J, that's a line feed, which is what Unix uses for the end of a file, end of a line. Windows, on the other hand, if you say hello and you hit enter, will store hello, but then it will store this \R and then a \n. This is a carriage return, which is ASCII code 13, and this is a line feed, which is ASCII code 10. And why does Windows store that? Well, because DOS stores it that way. And why does DOS store it that way? Because back not too far before DOS was a thing, DOS was, I think somebody in Seattle wrote this thing called the Quick and Dirty Operating System, QDOS. That's what became DOS. Bill Gates bought it for, I think, a few $1,000s and built his empire on it. but QDOS and programs like that are contemporaneous with an era when people were using typewriters basically to act as the output devices for computers, because we already had machines that could produce type that you could read, and people hooked these up to computers, right? So how does a typewriter work when you're typing a line of text and then you want to go to the next line? You grab that lever. How many people here have used a typewriter? I might need a picture.
I was there when you touched it.
Yeah.
Right? So you would grab this lever on the side.
That is a man, not a lever.
There's a lever. You would grab that lever and you would push, right? And that lever would do two things. It would take this rolling piece of rubber that holds your piece of paper in it, and it would move it all the way over to the right so that you're ready to start typing in column 1 again. That thing that holds the paper, that's called the carriage, right? So you're returning the carriage back to position 1. That's what a carriage return does. But if you just slide that over and you start typing again, you're going to type on top of what you originally typed. So you also need to turn these rollers on the end to move it up one line. That's what a line feed is. And that lever would do both. It had a mechanism that would both physically move the carriage back to position 1 and also scroll up one line. So when you hit that lever, it basically does a carriage return and a line feed. And so early file systems, right, store the end of a line as a carriage return and a line feed. So Windows still does that. So if you have a Windows file and you try to edit in VI, you see all these control M's in the middle of it. Right, that's the carriage return. And Zenity is still doing that because Zenity is running on Cygwin, which is on Windows. So if you say, give me an entry box using a Zenity -- entry, the thing that you get back will have whatever the person typed in with a control M on the end. Okay, to make this work reasonably, we want to strip those out, and we can do that with SED. And we'll talk about SED next, and then tomorrow we'll go through some examples. But it's a really easy thing to do. You just have to do something each time you get a result back from Zenity to throw away those control M's, those carriage returns. All right, so let's play with SED. So I have a file of foods with the name of a food, a type of the food, color of the food, and then the price of the food. So I'm going to play with a shortened version of this file to start with, so it's easier to see. So I'm just using this file F. It's got 5 foods in it. Okay. And we already talked about doing substitutions inside VI, right? You can say : s/old/new, right? So, and I think we said we can do this with SED, right? Substitute space with, a bunch of spaces in this file F. And so the first space on each line gets replaced with a bunch of spaces. And if I wanted to replace every space on a line with a bunch of spaces, I can put this special G for global at the end of my closing slash, and so it, it does that.
Question.
Yeah.
When you ran that line, or the line again, but with the G, why didn't it take all of those initial spaces and just
It's smart enough not to edit the stuff that it's just changed.
Oh, okay.
Yeah.
Interesting.
I thought it was just because you were still feeding in the file and you're not actually manipulating the file.
Well, that too. But you were asking why doesn't were you asking why these didn't get changed down here? Oh, okay, yeah, because this does not change the file.
Okay.
Right, so I can do this, but my original file is unchanged.
Gotcha.
I thought you meant why doesn't it substitute the spaces it just inserted with more spaces and go on forever.
Right.
Yeah.
Okay. Gotcha.
Okay. All right, so this is one way to use SED, right? Basically to take these things that we could type into VI and do them without using VI. And SED is called a stream editor. right? VI is an editor that we interact with. You say colon s slash blah, 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 right? Sed lets us do the same kinds of things, but we don't have to interact with it. We can specify a command on the command line that we use sed, right? Or we can put a command in a file and say, take the command in this file and apply it to, you know, foods or F or whatever. So it's a stream editor, it's a batch editor of sorts. And this is one way to use it, right? You just give it like a substitute command that we would put in VI and just apply that to this file. But it's something much more general than this. So let's look at the general behavior of sed. So sed is really aimed at manipulating lines. And tomorrow or Thursday we're going to talk about awk. Awk is focused on manipulating fields within a line. But sed is really looking at taking a line of text and doing something in response to that. It's processing things kind of a line at a time. And the general structure of this is sed program and then file to read. So for example, right, sed is the name of the command. That thing inside quotes s slash space slash bunch of spaces slash, that's the program, and then F is the file that it wants to read. And if you don't specify a file, it reads from standard in, like most commands.
If you type in stdin, does that also make it read from standard in?
No, that would look for a file called standard in. Right, so if you don't put a file name, it looks for standard in. And in each case, it takes the result of applying these edit operations and it prints it out to standard out. Okay, so it's a general sed program and a file to read. The file to read is actually optional. If you don't specify that, it reads from standard in. We can also say sed-f, and we can name a file containing a program if our program is more complex than just one line, and then we can specify the file to read, or leave it off and specify standard in. So here's our file F. It's got 5 foods in it. If I just say sed with a program that basically has nothing in it, and the file name F, all it does is read that file and copy it to standard out. Okay, this empty program says don't do anything special. But sed always has this behavior that it reads from the input, and each thing that it reads, it copies to standard out. And then it tries to execute the program that you specified on that line of input. Now my program doesn't do anything, but nonetheless it reads the first line, apple, it copies it to standard out, and then it says, well, there's no program here for me to execute. So it reads the next line, banana, copies that to standard out, no program to execute, reads the third line, and so on. So sed quote quote file name is like cat. It just reads the contents of a file, copies it to standard out. The -n switch says don't do that default behavior of each line that you read, copy it to standard out. So if I say sed-n, it will read the first line, it won't copy it to standard out, it'll execute my program which doesn't do anything, it'll read the second line, not copy that to standard out, execute the program that doesn't do anything, and so on. So this does nothing. Okay, but it's a really useful thing that we can make it do nothing. All right, so we have the option of a -n switch. Okay, so what does a program look like? It can be an instruction, or it can be a location followed by an instruction. And this location is a line number, so we can say if you're at line number such and such, do this instruction. Or it can be a pair of locations, which says if your line number is between that location and that location, execute this instruction. Or it can be a slash regular expression instruction, which
There's no
says,
column.
sorry,
There isn't a column option.
column.
Yeah. Like a column in the line.
Oh,
Or like
yeah, there's a lot more than we're doing here. It can be a pattern in between two slashes, and that pattern's a regular expression, which says if you read a line that matches this regular expression, then execute this instruction. And this location can be a line number, or it can be a $, which means the last line.
Can it be a first line?
It can be the first line, which would just be a 1. So it's like VI, right? We have a 1 because we know the first line's always 1. We don't know what the last line is in the file in general, but we can use $. To represent the last line. Same thing here.
I thought the $sign was the last.
It's the last character if you're looking at something based on a line.
Okay.
But if you're looking at the file, like if you're saying :1, comma something, you can use a $sign there.
Oh, weird.
So
Yeah.
we just assume it's like an end.
It basically means the end, yeah. In a regex, it's an anchor for the end. There's a lot of harmony in Unix, right, between different domains, which is why playing Rogue teaches you how to use VI, for example. All right, so we can specify instructions that should happen all the time at a certain line number, between line numbers, or when a pattern appears on the input line. So what are our instructions? Well, our first instruction is P, which means print. And why we're doing these first few examples probably won't make a lot of sense, but I just want you to think about the mechanics of what they mean, right? Why these programs do what they do. That's all I want you to get out of this for now. Not why in the heck would you want to do this, or couldn't you do this more easily some other way, right? There's no good reason for doing these, and yes, we can do these more easily some other way. But these are just illustrating some of these sort of mechanics of it that will build up into doing things that are really powerful. And kind of unique to SED. So let's play with the print instruction. So I'm going to do SED 3,5p on the file F. So what should this do? This will read the first line. It will copy it to standard out. And then if that line is somewhere between lines 3 and 5, it will execute the print instruction. Then it'll read the second line, do the same thing, read the third line, and so on. So this program right here, 3,5p, makes the following output. So what did I get here? I got the first line, apple, got read, got copied to standard out, because that's what SED does, so we saw apple appear. That's the first line. It's not between 3 and 5, so it didn't execute the P instruction. Read the second line, banana, copy it to standard out, because that's what SED does. It's not between 3 and 5, don't execute the print. Read the third line, Oreos, copy that to standard out. And now, since it's the third line, and that's between 3 and 5, execute the print instruction, so it prints the Oreos line again. And then same thing with Kiwi and Coke, those lines come out twice. They're coming out twice, once because SED always copies each line of input to standard out. And those are coming out a second time because, since they're between lines 3 and 5, we said print. Now if I just want to see lines 3, 4, and 5, this is where I can use the -n switch. So read a line, don't automatically copy it to standard out. But if it's between lines 3 and 5, go ahead and print it. So if I run that, I just get my Oreos, Kiwi, and Coke, lines 3, 4, and 5.
And then you could also do the thing where there's like if this pattern is here, then do these.
Yeah, yeah.
So if you wanted to, you could do like if cheap,
Mhm.
then print out.
Yeah, yeah. So we could do sed-n cheap F.
Print?
Okay. So that just prints our cheap foods.
Oreos are cheap.
Oreos are really cheap.
But there's like discount Oreos.
Oh yeah.
You can keep your Oreos.
Break it down by calorie, man. Oreos are a bargain. And they're vegan. All right, so we can, you know, print the fourth line of a file. There you go. Or the third line of a file, right? Just 3p. So that's kind of cool. All right, so P is for printing. Q is quit. So if I just do sed quote quote F, it reads all 5 lines, prints them out. Suppose I only want to print the first 3 lines of my file. I can use the following program, 3Q. So that says when you get to line 3, quit. So it'll read the first line, copy to standard out, second, third, copy to standard out, but then after the third, it will quit, instead will exit. So this will just print out the first 3 lines of our file. Or if I only want to print until I find a line that contains the word yellow, right, look for that pattern. If you find yellow, go ahead and quit. So it prints out my apple and banana, and then it quits. All right, so if we have a more complex program, remember we can say -F program file, and we can put a big program inside this file if we don't want to type it all on one line. So here's a bigger program, P1. It's got 3 lines, 3P, 4P, 4Q. So what is that saying? Print the 3rd line, print the 4th line, and then quit. Right, so 3rd line, 4th line.
Whoa. Can we run more views on it?
Yeah,
Yeah, nice.
definitely. All right, next instruction, append. So append lets us add something to the end of the input line. Lets us add a new line after a line of input. So here's a program P2, and it says on line 2, execute the following instruction. A, which means append, this was added after line 2. And then the second piece of the program just says P. It says print what the current line is. So if I do this, it reads the first line, copies the standard out because of the print. Reads the second line, appends this was added after line 2 to the end of it. So now the second line is banana, fruit, yellow, cheap. This was added after line 2. And then the P says go ahead and print that. And then it reads the 3rd line, Oreos, prints that, and so on and so forth. So we just appended something after the second line. All right, I is an insert. Append is after. Insert is before. All right, these match VI also. If you want to go into insert mode, you can use I or A to go after or before the current cursor position. So here's another program, P3. It says take the current input line, search for the pattern cookie. If you find it, insert the following before that line. Here comes a cookie. And then it says look for the word cookie on the current input line. If you find it, append the following after that line. That was a cookie. And then it says print the current line. So if I run this program, let's run it on our Whole Foods database, right? Then each entry with a cookie gets surrounded by, here comes a cookie, that was a cookie.
Whoa.
And if you wanted to do this in C, you could fget each line from a file. You could write something that searches for, a C, and if it finds it, sees if the next thing is an O, and if the next thing is an O, and then a K, and an I, and an E, and if it is, then you could print out this special thing ahead of time, and then you could print the current line, then print out that was a cookie. Otherwise, just print the thing that you fgot and put that in a loop. That's a fair amount of code, and it's fragile code. If you wanted to search for something different, you'd have to change that code, and if you don't happen to have 6 characters in your input, you might segfault and so on and so forth. And we can do it with sed with this 3-line program, right? Which, if you understand sed, is really easy to interpret and modify to do what you want to do.
But C would be more performant.
But C would be faster, yeah, if you wrote a good C program. But sed's pretty efficient. So here's the same program, except my insert, remember you can put a backslash at the end of a line and continue it on the next line. So here I put a backslash, and on the next line I just put another backslash. And so this is basically putting a new line before here comes a cookie and after that was a cookie. And so if I run this, right, then my cookies get separated by white space or yellow space.
Only 2 cookies?
Yeah. I think I was being healthy when I made the file.
Pete. Hot dog is unknown.
Yeah, totally. All right, next instruction C, which is change. So I can say, see if you have the pattern fruit on your input line, and if you do, change your input line to no fruit. And so my fruit is removed from the list and replaced with just this thing that says no fruit.
How does it know what fruit is?
It's searching for that pattern fruit, right, which some of these lines contain.
Oh, I see.
Apple.
So hot dog isn't a fruit, it's unknown.
Yeah, it could be a fruit. Probably.
Why didn't you put it as meat?
Does that mean that hot dogs are vegan? If you
Right,
go
it
with it?
depends. It could
Well,
be-
yeah, sometimes. They could very well be. What, did you have a question?
Oh, hot dogs unknown could be meat because burger right above it is meat.
Could be meat, yeah, but it's not clear that it's meat either.
Oh, that's true.
Kind of like spam. All right, so we know about substitution, right?
Mystery meat.
we go.
Now, could you make it pad them all in columns? So like.
That's
the
something
first
awk will
column
be a
should-
little better at. We could probably cobble some regular expressions that would do it, but awk will make it pretty straightforward.
No, bubble sorted by characters.
Yeah.
Almost with each character.
Bubble sort the list by the amount of characters.
So, so I did this. Substitute unknown with mystery meat, and then I used an instruction, write new file, which says if you match this pattern of unknown, right, do this substitution, but write that line into this file called new file. And remember, sed's default behavior, take each line that you read and produce it on your output, right, so we're seeing that. But new file ends up having these lines that match this pattern. So if I do something like this, sed-n, right, it doesn't produce any output, but it makes this new file.
Can I ask what more does?
More is just a way of looking at it's a way of looking at a file potentially one page at a time.
Okay.
So if you more
And then
a long file, it shows you the first page, and then you can space to
I
go
get
on
it,
to the next
yeah.
one, and so on.
versus cat.
Versus cat, which just throws
Yeah.
it all out. So this is another instruction, write file name. And that can be useful.
What happens if you put a space after W or B or whatever? So W
That's-
space new file.
Let's try with a space. Let's do a dash in, so. Alright, so it writes out lines 2 through 5. So space is harmless.
Okay.
So none of this is changing our file. Our file is just a source of input. Okay. If we really want to change our file, though, we can add another switch. So I can say -I, and I can put in an extension like .backup copy. And I can do my program, and I can put in my file name. Let's do a -n. So it doesn't produce any output. But if I look at my, no, I didn't produce any output. I forgot to print. But before it does that, it makes a copy of your input file, right, and saves it in input file with whatever extension you specified after -I. So, did I get mystery? Yeah. So that's substituted unknown with mystery, so there's my updated foods file, right? So it read from the foods file, but it actually applied those changes to the file itself. But it makes a backup copy first. right, which is what it actually reads from the input, and then standard out gets written to that file.
And is there any way to just manipulate the file without making a backup?
It's generally pretty hard to do. At the very least, it's risky to do. Some commands can read from a file and also output to that file at the same time, but it's generally avoidable, generally best avoided. Yeah.
You'd have to read everything, store it in like RAM or something, and then put it back up.
Yeah, and not all commands do that. So if you know that it's only going to read one line at a time, you might be able to get away with it. But if you're actually writing into the same file and you write a line that's longer than the line you just read, you can start stepping on things ahead of yourself and so on. So usually you want to copy it into an input file and then read that and write to the output. Okay, we'll continue this tomorrow with the negation, which will let us negate the conditions under which an instruction is applied. So we'll play more with this tomorrow. We'll look at more examples. And then once we finish sed, we'll go ahead and we'll talk about awk, which is manipulating fields within each line.
AWK?
AWK, or it's usually called Gawk on Linux. It's the GNU version of awk.
What's that?